Good morning, everyone. Today's talk will be about molecular gastronomy. Here is the plan of the presentation that will follow. I will begin with an introduction and define what molecular gastronomy is. I will then talk about people who made it what it is today, the techniques, the tools, and the food additives used by the chefs. I will then move on to the pros and cons of molecular gastronomy. I will have a quick word about how molecular gastronomy has developed in Belgium, and we will finally draw a conclusion to this presentation. First of all, the introduction. When I chose this subject, I thought I was going to talk about very small dishes prepared with particular care by great chefs, but molecular gastronomy, or more generally molecular cooking, is not only dishes with quite small portions. Molecular gastronomy dishes do have quite small portions, mainly because it takes time to make one. Pere Castell's definition of molecular gastronomy is the application of scientific methodology and concepts to the culinary process, such as noting down temperatures and measures or establishing systematic reproducibility. In other words, how to ensure that the process can be repeated in exactly the same way. Another definition is proposed by Adrian L. Fulga, and according to him, molecular gastronomy is a subdiscipline of food science that seeks to investigate the physical and chemical transformations of ingredients that occur while cooking. Molecular cooking is one application of molecular gastronomy. It means cooking with modern tools. It takes advantage of many technical innovations from the scientific disciplines. The term molecular gastronomy might not be the one we hear the most, as molecular cooking or molecular food are used to refer to the same concept, but it is the one that truly defines what it is. Cooking is an art, not a science, which gastronomy is. Cooking is seeking to bring flavors together according to what the cook feels, to how the preparation tastes. Gastronomy has a similar goal, but it seeks to understand the scientific reasons of cooking. For example, why would such a wine would go well with meat rather than with fish? Or why does a soufflé rise? I will now tell you how this unique gastronomy was born and how it has evolved until now. The term molecular gastronomy was first coined in 1988 by these two men, Hervé Vis, a French chemist and cook, and Nicolas Curti, a Hungarian physicist. But they were not the first to adapt scientific processes to the culinary ones. In 1943, Evelyn J. Halliday published a book dealing with the chemistry of varied foodstuffs, such as milk, baking powder, vegetables, and their uses in cooking. Even earlier, in the 19th century, Marie-Antoine Carême recorded his observations on how to make a good broth. He was the very first person to be called a chef, and is famous for being the one who elaborated what is now known as the Grande Cuisine. Curti and this aim was to bring together the trends, the physical and chemical processes in one single stream. It led to the establishment of a revolutionary practice that is widely spread in today's cuisine. In 1969, Curti gave a lecture called The Physicist in the Kitchen at the Royal Society of London, in which he proved the use of scientific tools in cooking. He made a meringue in a vacuum chamber. He proved the digestion of proteins by fresh pineapple juice, and he cooked a reverse-baked Alaska, which means it was hot inside and cold outside. And he cooked it in a microwave oven, a device that was just invented a few years before. He was a supporter of low-temperature cooking, and during that lecture, he repeated a recipe developed in the 18th century. He left a 2 kg lamb joint in an oven at 80 degrees for more than 8 hours. After such a long time, the outside and inside temperatures of the lamb joint were equal, around 55 degrees Celsius, and the meat was really tender and juicy. It proved that low temperature cooking helps to preserve the tenderness and the taste of the meat. Let's now talk about the techniques, the specific tools, and the food additives molecular chefs are using to create their menus. First, the techniques. With jellifications, flavors into pearls, spaghetti, ravioli by adding gelling agents. solidification, they trap flavors into bubbles that burst into one's mouth. With emulsification, they create colorful foams to enhance aromas. And with deep freezing, they plunge the food into liquid nitrogen during 1 or 2 seconds to harden it. It gives a crunchy outside while still having a liquid inside. It is particularly appreciated with chocolate desserts. Let's now talk about some unusual tools that are used in molecular gastronomy. The first one is the anti-griddle. It is used to freeze or semi-freeze the food you place on its chilled metal top. It has a constant temperature of about minus 34 degrees Celsius by pumping a refrigerant through a compressor to remove heat from the surface. The product placed on the tops therefore has a crunchy outside and a soft inside. The vacuum machine is used to vacuum pack food. With this method, air is removed from the packing before it is sealed. It can be done manually or automatically, and it is usually done to preserve the food longer. It reduces the risk of the food to be freeze-burnt by preventing it from exposure to the cold or dry air. When this method is used in cooking, the food sealed in the plastic bag has to be poached and simmered to be cooked. It is used to preserve the flavors of the food as long as possible. Since they are kept in the plastic bag, they enhance the taste of the dish. Molecular chefs also use whippers to create foams, espumas, mousses. You place the mixture for foaming into the whipper. You close it and charge it with 1 or 2 bulbs of nitrous oxide depending on the desired consistency. You shake the whipper and then dispense it as you want. They also use a syringe and small pipes to create flavored and gelatinous spaghetti. They use droppers to put only drops of liquid on a plate rather than a full spoon. Or liquid nitrogen to flash freeze food. Now about food additives. Maltodextrin is one of the food additives that are used by molecular chefs, and it can turn a high-fat liquid into a powder. Enzymes are also used as food additives. For example, fresh pineapple and papaya juices enzymes are used to tenderize the meat by decomposing the collagen. The juice is directly injected in the meat with a syringe. It fastens the process of digestion of the proteins that begins when the animal dies. But be careful not to wait too long before eating your meat, or it will end up looking like a terrine. Other food additives are used in molecular gastronomy, such as alginic acid. It absorbs water quickly and is used as a gelling and thickening agent. Soya lecithin is used as a emulsifying and a lubricant agent. Let's now talk about the pros and cons of molecular gastronomy. We will start with the pros. Molecular gastronomy has brought scientific tools in the kitchen to help the chefs prepare more and more sophisticated but also more and more expensive dishes. Science has contributed to bring more precision in the culinary process. The control of temperatures and timing is better than before. It has allowed the use of new products such as dyeing agents or new devices such as the anti-griddle. It allowed new recipes and techniques to be developed, as well as the appearance of a whole new gastronomic movement. It opened the path for the chefs willing to adopt such methods, and it allowed them to express their imagination and their creativity by designing fancy dishes or by combining foods that would not have been put together otherwise. As molecular chefs attach importance to the respect of a set of chemical, physical, or nutritional rules, some of the molecular gastronomy dishes are healthier than those of the traditional gastronomy. They are also far more lighter. For example, you can have a bit of soup, some vegetables, and that's it, you have your meal. If you compare it with a braised knuckle of ham, the difference is obvious. The knuckle of ham looks tastier, but is far more calorific and heavier to digest. It must be noted that restaurants that embraced this way of cooking are now known all over the world, and some of them are being claimed as the finest restaurants of the world. For example, El Bulli in Spain was awarded Best Restaurant of the World several times, El Bulli is a 3 Michelin stars, and to eat there you'll have to pay around 250 euros for one person. The Fat Duck in England is another molecular gas restaurant, and its chef, Heston Blumenthal, was awarded the Chef of the Decade in 2013. The Fat Duck also has a 3 Michelin stars, and then you will have to pay 220 euros for one person. If you want to have dinner in one of those restaurants, you will have to wait at least a whole year before you get your turn, because the waiting list is quite long, and of course you will have to pay the price. The cons of molecular gastronomy. The idea of a molecular way of cooking has frightened people, because people usually do not associate science with cooking, and because they feel uneasy as soon as scientific words or words referring to non-visible things such as molecule are pronounced. According to physicist Davide Cassi, the scientific side concerns people because it makes them think of something they don't understand or don't see. Some chefs have tried but failed to change the name of the field. David Cheng argued that it's never going to lose the name molecular because it's what everyone knows it by. Molecular gastronomy can deceive people in that it can change the flavor of food. How can we know when, for example, we are expecting fried eggs, that the eggs we receive will taste mango and vanilla? If it is our only experience with molecular gastronomy, we can be quite disappointed and never want to try it again. However, science has always been involved in cooking. People were just not aware of it. Take sugar as an example. It doesn't grow on trees, it is produced industrially, but people are fine using it every day. But when chefs speak about maltodextrin, which is a sugar substitute, which is also produced industrially, people stop trusting them. Let's now have a quick word about molecular gastronomy in Belgium. There is only one restaurant in Belgium of whom can be said that it is involved in molecular gastronomy, and it is L'Air du Temps in Égezé, north of Namur. It opened in 1997 and received its first Michelin star in 2000 and a second one in 2008. It moved in Égezé in 2013, and it is located in a 5 hectares estate where the chef, Sang-Hoon de Gendre, grows vegetables, herbs and plants. As a conclusion, we can say that yes, molecular gastronomy can be kind of strange, tricky, or make you feel uneasy, because you never know what the dish will taste or look like. Science is cooking is not something to be afraid of. Saying you don't want science to be involved in cooking is not sufficient a reason to try it. Since its very beginnings, molecular gastronomy has evolved to become a fully fledged field of the gastronomy world, and it attracts more and more young chefs willing to dive into it every year. The best way to put aside all one's apprehensions is to go and eat in a molecular restaurant. Of course, you'll have to be patient and be ready to pay whatever the price. But, as it is often said, when you love, you don't count the cost. Thank you for your attention.